In our Beginner's Guide to Supports, we covered how OrcaSlicer generates supports. In the Intermediate Guide, we explored interface quality, contact distances, materials, speed, and cooling. Now we're moving into advanced support techniques. Controlling exactly where supports appear, tuning tree support geometry, creating zero-gap soluble interfaces, ironing support interfaces, and diagnosing difficult models through preview. Before tuning individual settings, check the model's orientation. A small rotation can turn a large horizontal overhang into a printable slope, move support marks onto a hidden surface, or replace a difficult support structure with a manageable bridge. For large models, cutting the design into printable sections may produce a better result than building an enormous support structure. Advanced support tuning begins by reducing the problem before trying to solve it with more material. Support painting gives you direct control over where OrcaSlicer should generate or avoid support. Left-click paints support enforcers. Right-click paints support blockers, and Shift plus left-click erases the painted selection. The circle and sphere brushes are useful for precise corrections. Fill selects connected surfaces based on the Smart Fill angle, making it faster to cover an entire overhang. Gap Fill can clean up small unselected areas left between painted facets. Enable on highlighted overhangs only when you want the brush restricted to surfaces identified by the Highlight Overhang Areas angle. For difficult internal features, use Section View to move through the model and expose surfaces that would otherwise be hidden. With an automatic support type, painted regions can correct or refine Orca's generated supports. With a manual support type, support generation is limited to the regions you have explicitly enforced. After painting, always slice the model. The colors show your instructions, but preview shows the supports OrcaSlicer actually generated from them. For larger or more geometric regions, use Support Blocker and Support Enforcer volumes. Add one from the model's right-click menu, then move and scale it over the area you want to control. These volumes are useful for cavities, holes, mechanical clearances, and broad surfaces that would be tedious to paint manually. They influence support generation within a region, but they do not give you complete control over the exact route taken by a tree branch. Slice and inspect the result after positioning each volume. For tree auto supports, support critical regions only can limit generation to features such as sharp tails and cantilevers. This can greatly reduce support volume, but every remaining unsupported area must be checked carefully. The available tree settings change with the selected style. Organic and tree default expose organic controls, while slim, strong, and hybrid use a different set of branch controls. Tip diameter controls the size of the contact tips used by organic supports. Smaller tips reduce contact marks but can become fragile. Larger tips provide more reliable contact but may be harder to remove. Branch distance controls the spacing between neighboring support nodes. Closer spacing can create more support coverage, while wider spacing produces a lighter structure. Branch density controls how densely OrcaSlicer generates branch tips. Increasing it can improve overhang support, but it also makes removal more difficult. If you need a dense surface beneath the model, adding top interface layers is usually preferable to pushing branch density extremely high. Branch diameter controls the initial thickness of the support nodes. Increase it when tall branches wobble, separate, or fail during printing. For organic supports, branch diameter angle controls how quickly branches become thicker toward the bottom. A value of 0 keeps them at a uniform thickness, while a small angle can produce a wider and more stable base. Branch angle controls how far branches may lean to reach an overhang. A higher angle lets them travel farther horizontally, but aggressive angles can create less stable structures. Preferred branch angle influences the normal path used when a branch is not avoiding the model. Lower values keep branches more vertical and stable. Higher values encourage them to merge sooner. Finally, auto brim width lets Orca calculate a brim for tree supports. Disable it only when you need to enter a specific tree support brim width yourself. When tuning trees, diagnose the failure first. Improve contact with tips or interfaces, improve stability with diameter, walls, and brim, and adjust routing with distance and branch angles. A multi-material printer can create a nearly continuous supported surface by using a soluble interface. Keep the main support body on the regular model filament and assign the soluble material only to the support interface. This saves specialty material compared with printing the entire support structure from it. For a true soluble contact interface, top Z distance can be set to 0. Setting interface spacing to 0 creates a solid interface beneath the model. Because the interface material can be removed by dissolving it, the usual air gap is no longer required. This can significantly improve flat undersides and complex internal surfaces. Do not use a 0 gap blindly with normal same material supports. because the interface may fuse to the model. It should be used only with a tested soluble or deliberately non-bonding material combination. Check the filament preview carefully. Confirm that the model-facing interface uses the intended material, and review the number of filament changes, purge volume, prime tower, and total print time. For large, flat supported surfaces, OrcaSlicer can iron the support interface before printing the model above it. Ironing support interface adds another low-flow pass at the same height to smooth the interface. When enabled, OrcaSlicer also makes that interface solid. You can select a rectilinear or concentric pattern and adjust the ironing flow and line spacing. Too much flow can over-extrude the interface, while very tight spacing increases print time. Because this creates a dense and smooth contact surface, it may also make same material supports harder to remove. If the option is unavailable, make sure the print has at least one top interface layer or a raft. A raft is a specialist solution for models with poor bed contact, severe warping, or support structures that need a larger foundation. Raft layers raise the object on a printed support platform. Contact Z distance controls the separation between the raft and the model. A smaller distance improves support, but makes the raft harder to remove. A larger distance releases more easily but can produce a rougher bottom surface. When a soluble interface is used, the raft contact distance is ignored because the soluble material can contact the model directly. Advanced support tuning is not about maximizing support. It is about placing the minimum reliable structure exactly where it is needed. Control the contact regions, stabilize the paths, match the interface to the material, and let Preview verify every decision. That completes our OrcaSlicer support guide series, from the fundamentals through full advanced control.